Greetings and salutations, everybody. What is up? Hey, what's up? So we're on part 3 of the grade 6 Show Your Work Hottest Math Problems. I have a link to the GregsTutoringNYC.com/hottest-math. Has a link to a whole bunch of previous videos, multiple choice, and Show Your Work. We have a couple parts to this. Again, if you're in grade 6, you may want to peek at the grade 5 multiple choice, the grade 6 multiple choice, and the grade 7 multiple choice, just to kind of give yourself some, run the full gamut of wiggle room there. And if you're in grade 5, check out the grade 5 Show Your Work problems in addition to the ones I did for grade 6 already. I haven't done the grade 7 and grade 8 Show Your Work yet, but I've done the multiple choice ones. So again, go to that link and have a great time. On that note, running this channel is a lot of work for me and a lot of effort. It's very rewarding as well, but please don't forget to subscribe so you get notified for other videos I'm doing. When I do this series, I'm going to do other series. The channels mainly focus on SHSAT, but I do a lot of other stuff as well, including the ISEE, the SSAT, the TACHS, the BCA, you name it, the PSAT, the SAT, the full gamut, including grade 9. I might stop focusing on that. And I might run this series doing the same analogous kind of thing for ELA. That's harder because the passages are stuck in the middle of it and the problems are not bite-sizable. But in any event, speaking of which, my voice is giving out. So let's jump into this. And this is going to run about an hour. Catching this on the replay, you can pause it, try to answer the question yourself, and go on. I'm trying to explore numeracy issues, so I'm going to explore multiple alternate solutions in many cases, and just go on sidebar conversations and things like that as well, just to make sure you're proficient. As much as this is about solving each unique question at hand, like 52 here, it's also about the greater issue as a whole, mathematical concepts, mathematical proficiency, mathematical mastery, numeracy, just critical thinking, etc. So that's what we're about here. All right, so we have a word problem, and we're going to start taking it one step at a time. Just let me make sure we're good here. Yes, we seem to be. Okay. I just want to make sure I'm not recording into nothingness. And that's good. Yep, we got that. So Dana and Monique are dog groomers. Totally awesome, man. Dana's workday is 10 hours, so Dana's 10, and Monique's workday is 8 hours. Dana and Monique each work 40 hours per week. So it seems to me if we stop right there, that if they're working 40 hours, that for Dana, if she works 40 hours, and she works a 10-hour work, 10 hours per day, that Dana works 4 days a week. Okay, I'm just trying to understand what they're telling us. Okay, Monique also does a 40-hour week, but she works at most 8 hours a day, so she works 5 days a week. Okay, if you will, that's their rate. 4 days a week versus 5 days a week. Okay, so we're done with this here. Okay, on Monday, Dana, on Monday, she groomed 15 dogs in that 10 hours. Okay? Okay, so if we're using this 40 thing here, we can write that as a ratio. She did 15 and 10. Okay? Because it's going to eventually ask for the rest of the week. Okay? Right there. So what we want to do is set up that ratio as a proportion and ask how many dogs did Monique do for that time frame. So we can do the cross product, or we can just notice this times 4, so that must be times 4. So that DM would end up equal 60 there. Okay, you guys can do the cross product on your side as for your own case. Okay, and Monique on Monday groomed 10 dogs in her 8-hour day. So same thing, we have a 10 is to 8 equals Monique's number of dogs on Monday over 40. So I can see that's times 5, that's times 5. So Monique did 50 dogs, right? This is the number of dogs. It's always good to write the units in just to keep yourself track of it. So let's go through this again. Dana and Monique are dog groomers. Dana work day is 10 hours and Monique is 8. They worked 40 hours per week. Dana grew 15 dogs in 10 hours on Monday, and Monique groomed 10 dogs in 8 hours. Okay, then it says they each earn $12.75 for each dog groomed. Okay, that's going to be critical for us. Okay, assuming that for the rest of the week, Dana or Monique groomed the same number of dogs per day, per work day. So that's what we emphasized right here in doing this. Okay, that box there is what they did for the rest of the week. So Dana groomed 60 dogs in total for the week, and Monique groomed 50 dogs. Okay. What will be the difference between their weekly earnings? Okay, so there's a couple ways to solve this. Let's do this the hard way first. So if Dana did 60 dogs at $12.75, then we'll just multiply it by the number of dogs she did and get the full price. So that's 0 there. 6 times 5 is 30. 0, count my 3. 42, 45, 4, 12, 16, 1, 7. All right? So we have 1, 2 decimal places there, 1, 2 decimal places here. So it means that she got, this is for her. So she made $765. So for Monique, she did 50 dogs at $12.75. So we're going to multiply that by 50 and get her total profit. That's 0. 5 times 5 is 25. Carry the 2. That was a 7, so that's 35. That's 7. 3, 5, 10, 13, 1. So we get 637.50, I believe, if I did that right. We have 2 decimal places here, 1, 2. We move that over 1, 2. We get the point there. So now we have to subtract the 2 of these. So we're going to get 765. 0.00. We're going to add the zeros because she has 50 cents here. Minus 637. .50. Okay. So if we did all that right, and let me just double check some of that math. 0, 3, 42, 45, 4, 12, 16, 1. Yep. 765 looks right. This is 5 times 5 is 25. 2, 35, 37, 3, 10, 13, 1, 5, 6. Okay, I believe the 2 numbers are correct. We can't borrow, so we have to take from here. That's a 1, so we get 0.50 here. We can't take 7 from 4, so we have to borrow one more time. That's a 7. That's a 5, so that's a 2. So we get 127.50 is the difference between their weekly earnings. And remember, the word difference normally means subtraction is involved. Okay, so that was the first way to do it. The second way to do this problem which is that if we simply note that 60 dogs for Dana, what was her name? Yeah, and 50 dogs for Monique means there's a difference of 10 dogs between them. So it's just 10 times the number of dogs that were the difference. The 1275, and that equals 127.50 again. So we get the same answer. This one was so much easier than going through all that. So part of this is being astute and making observations within what they're trying to ask you. So this involved processing a word question. It was multiple steps. It involved the multiplication table. If you did it that way, even the 10 times 12.75, still some multiplication. It was multi-part. It involves setting up these ratios here, these two here, and even these two here, to be able to get that. So there was about 3 or 4 steps, all intertwined with each other on this question. But I guess the main concept they were trying to hit home was ratios and proportions. And if you just take it one sentence at a time and logically break it down, sometimes, I mean, I read this through already. So when I stop at, say, here and here, I'm still considering what's down there. I'm just talking out loud for you guys. All right. So there's issues like that. Let me just make sure I answer the question. Yeah, it's asking for the difference. Show your work. So we're going to get the 127.50. And it should be dollars in the choice here. Yep, there's dollars. So we use that partial clue all the time. Some students get bogged down in the answer, and they assume the first calculation, if they did it this way, they assume this is the answer. It's not. It's not. Okay? Some get so bogged down they think this is the answer. It's not. It's not. You have to do the subtraction. You don't do the subtraction, you don't get the right answer. Okay? Some will also do the 60 minus the 50 and think the 10 is the answer. Be careful, be careful, be careful, guys. Okay, so that's that question. Okay, technically there's an illustration here. It's the formula they're giving you. This should leap out at you guys that F equals 1.8 C plus 32, okay, is the temperature conversion formula. So let's go and read what it says. The formula below is used to convert Celsius, C, to Fahrenheit, F. Okay, so it's C times 1.8 plus 32 gives you F. The high temperature in the mountain city was 15 degrees Celsius. Okay, what was the high temperature in Fahrenheit? So all we're really going to do is plug that in. We're going to get equals 1.8 times the 15, okay, plus the 32. So we're going to need to go off on the side. If you know 18 times 15, which you should, I keep suggesting you guys know up to 20 by 20. If not, you have to multiply it out. And this is not 18 by 15, this is 1.8 times 15. So 8 times 5 is 40. Carry a 4, 5 plus the 4 is 9. Then we get 8, 1, 0, 8, 16, 17, 1, 270. We're going to double check that by flipping it. Actually, we move a decimal 1, so we move the decimal 1, so we get 27. We're going to multiply that upside down just to be sure we get the same answer. 8 times 5 is 40, 0, 4, 8, that's 12. And then we do 5, 1. We get 0, 7, 2. Move over one del place, and we get to 27. A lot of students think this is the answer, but you still have to drag the 32 back into there. Okay, so we get 9, and we should be getting 59 here. Okay, be careful with this. There is another way to solve this, and I believe I explained this a couple of videos back, either at the end of grade 5 or also in these grade 6 part here, which is that this 1.8C, if we want, we can do F is equal to, so 1.8 is 1 and 8 tenths. Okay, so that's equal to 18 tenths. Okay, so that means when we come down here, F is equal to 18 tenths times C plus 32. Well, C was 15, so we get 18 over 10 times 15 plus 32. Okay, we can divide, we can do a bunch of stuff because 2 goes into 5 and 18, and 5 goes into 10 and 15. So it depends how you want to do this, which way you want to go. I'm going to divide 5 into 10 and get 2 here, and 5 into here and get 3 there. Okay? Okay, and then I'm going to take the 2 and divide it into the 18 and get 9. So on the top I have 9 times 3 is 27 plus 32. Okay, so that's another way to do it. Obviously when you add that again, you get to 59. Okay, the slightly related third way to do it, which is you could have just, let me change the color of this one more time. It could have leapt out at you'll write 18 tenths, so F is equal to, you could have wrote 9/5 from the get-go times 15. Okay, which is normally the way this formula is given, by the way, plus 32. Okay, and you can do 5 into here 3 times, and then you can still get to 27 plus the 32. Okay, and we get the 59 there. So it's just a plethora of ways to do this. Okay, so this is really just making sure you know how to do substitution of values, in this case the C, and apply the algebra correctly. This was not F is equal to 1.8 of C plus 32. There's we're not doing 15 plus 32 and getting, what is that, 47. We're not taking 1.8 times 47. Okay, we're not doing that. That's not what this expression here means. Okay. What else can we say about this? Anything else? It was fairly straightforward. A lot of kids got this wrong though. I'm assuming they forgot to add the 32 back in here. No matter how they solved it, this is a gotcha often. You get so bogged down with problems sometimes and questions that you lose sight. It's always worth rereading the whole thing. Take your time, reread it, and try to make sense out of it. All right. It's an unfortunate consequence of some of this stuff, but that's part of what you're being asked to do. Your attention to detail is important. You just can't go willy-nilly without considering that kind of a thing like that. Okay. And the only other thing is, remember, this decimal point has to be the 27. It's not 270. Some students get to 270 to do the math part right, and they add 32 to it, right? And they get 20, they get 302. Okay, it's not 302. All right, so be careful. All right, so that's 53. So that's testing just multiplication. It's testing basic operations. It's testing that you understand the core level algebra of an equation. And they're asking just again, that second subtle hint is Fahrenheit. Okay, a lot of students get this question wrong. There's probably, just like the example I just gave, there's probably a lot of reasons why. So let's try to take it in pieces. A seamstress needs to cut 15-inch pieces of ribbon from a roll of ribbon that is 9 feet in length. So let's visualize it. There's a 9-foot ribbon. That's 9 feet. Okay. And visualizing a problem is sometimes worth it. It has to be the right visualization. And I'll say more about that later maybe. So it's being cut into 15-inch parts. And so each little part here is 15 inches. That's 15 inches. Even over here, this is 15 inches. Okay. All right. So we either need to convert these 15 inches into feet or this into inches. So to convert feet, we need, you should know that 12 inches is 1 foot. Okay, the feet cancel out and we're left with 9 by 12. You guys should all know that's 108. We're not even going to do that inside. So that's 108 inches. So we kind of redefined the problem. A seamstress needs to cut 15-inch pieces of ribbon from a roll of ribbon that is not 9 feet now, it's 108 inches. what is the greatest number of 15-inch pieces the seamstress can cut from 5 of these rolls. So this purple thing here, there's a second long roll. There's a third long one. And these are all supposed to be 108 inches. Okay, we cannot say it's 108 times 5, okay, which was 540. Okay, that is not the total that we are able to work with. The reason why is because there may be a little left over at the end of each ribbon after the 15-inch thingies. So this may have, let's say the ribbon was 150 inches, right? We know 150 divided by 15 gives us 10 15-inch pieces then, right? If it was 150 inches, right? But let's say it was 151 and there was a little 1-inch thing here, okay? So we had 15 ribbons, 15 of the 1 inches add up to an extra ribbon, but that's not what the question says, all right? So let's use the real numbers that the problem has. So what we need to do is take the 108 and divide it by 15, okay? All right, so 15 goes into 1, no. 15 goes into 10, no. 15 goes into 108, okay? Let's try 6. 6 would give us, what is that, 90? 0, 3, that's 90, so that's too small. Can we add one more 15 to that? I think so. So 15 times 7 is 35, 3, we get 105. So 7 goes into there with 3 left over. So what we get is 7.2, or 7 with 3/15 left over. So these 7.2 are 7 and 3/15, because that's the same as 1/5, right? And 1/5 is the same as 0.2. All right. So it means we can get 1, 2, 3, 4. If this was 15, that's 15. That's 15. That's 5. And let's say this whole last piece here is another 15. Okay? Right? Because if we do 15, well, we just did it. We did the thing here. There's 3 more inches at the end of here that can't fit within a 15-inch piece. All right? And that's why we can't do this multiplication here, because there's 3 more pieces on each. So even though each one is left with 3 inches at the end, and you could argue, well, those 3 inches times 5 is equal to a 15. But that's not what the question is asking. It says, what is the greatest number of pieces? Of 15-inch pieces, okay, these would be 3-inch pieces that we add together. Okay, they're not 15-inch pieces, they're 3-inch pieces. So unless it said we're allowed to glue them together, okay, it doesn't say that. It says, what is the greatest number of 15-inch pieces? Okay? All right, so that's critical there. So since we can only get 7.2 on each one, and we have 5 rolls of the ribbon, means we can only get 7 times 5 equals 35 out of it. Okay? So 35 should be the answer. Okay? We cannot round this up to 8 and do 8 times 5 equals 40. Again, that's not what this problem's about. There's not enough space at the end of these. Okay, we just showed there was only 3 inches at the end of them. So we can't make believe that each of these 5 strips is actually longer than they are. You can't do that. That doesn't make sense. So it does mean at the end of this, we're going to get 35 15-inch pieces and be left with 5 3-inch pieces as well. But they're not asking us how many 5 3-inch pieces they have. They're only asking us how many 15-inch pieces they are. So this is about equal parts only, right? It's about rounding down, rounding off in this case. Okay? Yep. So we can't do that. So this is about equal parts. It's about making word problem analysis, critical thinking on it, and it's about multiplication and division as well. All right. So again, a lot of kids got this wrong. Just take it a piece at a time. You have to do that extra analysis. I suspect a lot of kids either went to this 8 times 5 equals 40 thing, or they took that last piece at the end of there, which makes a 15-inch piece, and they added 1 to it to get a 36. Okay, so you did as close, but you kind of misunderstood what the question was asking. All right, so we're on a roll still here. Yeah, I'm not sure there's much else to say about that question. And then again, we use the head pieces. Right, and again, you're giving these problems in whatever form, you're normally going to get that hint or not on your screen. I have a smaller screen here, so we're scrolling back and forth. Okay. It is recommended that 1 fire extinguisher be available, so 1 FE, for every 6,000 square feet. Okay, write and solve an equation to determine X. So if you don't write this equation, you will not get the points for writing it. The number of fire extinguishers in a building that has 135 square feet. So it seems to be the number of fire extinguishers, to me, needs to be the total square feet over the unit square feet. I can put U there, I guess, which basically means we're going to have X is equal to 135,000 over 6,000. Yeah? Okay, so we can now solve for it because we wrote the equation. It's that simple. X equals 135,000 over 6,000. That's all they're looking for. Okay, we can get rid of these 2 zeros, those 2 zeros, those 2 zeros. So now we have 6 goes into 135. That's all we're looking for at this point. Okay, I know it doesn't go unevenly, so I'm going to add those zeros just in case. 6 into 1, no. 6 into 13, twice with 1 left over. 6 into 15, 3 times is 18, so it goes into there twice again. Okay. 12, we got 3 left over. 6 into 30, 0.5. So this one is fuzzy because it doesn't say what would be the number of fire extinguishers we need to order. So technically the raw answer is 22.5, either 0.5 or 1.5. We could use either one. But it says write and solve an equation to determine the number of fire extinguishers needed. Okay, this is slightly different than, say, the example before where we did that rounding. So it's a little ambiguous what they're looking for here. If it was something like how many to purchase, since they need more than 22, that would kind of mean rounding up to 23. All right? So there's one interpretation of this question where that's satisfactory, the 22.5. There's another where it's impractical because how do you get half a fire extinguisher? All right? You know, you need a full one, maybe half empty or a smaller one or something, but that's not what they're saying there. They're saying 1 fire extinguisher for every 6,000 square feet. So I can see some scenarios where saying you need 22.5 could actually make sense. They're just trying to assess what needs to be done, right? So I would go for the 23 though, because that seems to be the more sensible answer. But that's basically what's going on here. So we started out with a ratio. Then we had to write the equation, okay, and then we had to solve it. So it was easy to get rid of those 3 zeros. You don't really want to do 6,000 into 1. I don't know what just happened there. Got a magnifying glass. Yeah, wait a second. Something's freaking out with my computer. 135000. You don't want to be doing that. At least I don't. If you guys want to do it, go for it, but I don't. Let's see what could have gone wrong here. Some students will be inclined to go 6,000, 12,000. 18,000, and just start counting up to there. A more proficient student might do that and then realize, oh, if I do 10, 10 of them gives me 60,000. Right? And another 10 would give me another 60,000. So now you would be up to 120,000. And then they would figure out how to get the number 6,000s from 120,000 to 135,000. But that's, you're in grade 6 now, guys. You don't, that's not the way to really be solving this. Mathematically, it works, and you should still always keep that kind of thing in your pocket. But for something like that's just too much. By the time you figure out the scheme by 10, by 5, by 2, by 1, by whatever, it can start getting whacked out. Also, some students just go 135, 0, 0, 0, minus 6,000. No, that's not what they're asking. Another set of students will do 135,000 plus 6,000. No, that's not what they're asking. Okay? And you should be able to view this and kind of figure it out. That 6 times 2 is 12. So you know the answer is not 2 because 6,000 is so far away from 135,000. But your estimate should be like 21 or 22. So to actually get to 22.5 and eventually the 23, you should be able to be estimating this and figuring that kind of stuff out. All right? And at the end of the day, it's really about the 6 versus the 135. So we're going to set up that division. That's a ratio, actually, and just solve it at that point. Okay? Let me see how we're doing on time. All right, we're half an hour or so. Let me see what these problems are. And again, we got our clue for our extinguishers. All right, so this question starts getting a little whacked out super fast. So we have an illustration. It's a smaller cereal box. Okay, it has the length, and again, it's arguable which is which, but technically this is the length. That's the width. No, wait, I did that wrong. That's the height. That's the length, and that's the width. Okay, traditionally, technically it doesn't matter which we use. Actually, let me just erase these to make sure we're clear and there's no gobbledygook on the screen. So this is the height. Okay, the longer length is normally the front is the length, and this is the width. I don't know if the illustration has anything to do with anything. They're probably going to ask us for the volume. Okay, so there's really not anything else there. So let's see what we can do. A company sells cereal in 2 different size boxes. The smaller box has the dimensions shown below. So this is a 12 by 2 by 7 3/4. Depending on how you look at it, you could also say it's a 7 3/4 by 2 by 12. Okay, the height of the smaller box is 80% of the height of the larger box, while the other 2 dimensions are the same. So that means we have a second box. And my drawing here is horrible, but that's what we're going to get. Okay, so technically this is the larger box because the one they gave us was the smaller one. So it's saying the height is different, but the length is still going to be 7 3/4, and the width is still going to be 2. And it tells us that the height of the smaller box is equal to 80% of, so I'm going to call this the height of the smaller, the height of the larger. So this is the height of the larger over here. Okay? So probably we need to compute that. And then it says eventually what is the difference in the volume of the 2 boxes. So we need to compute the volume of both boxes, subtract them. That's what difference means again, all right? So there's a couple of ways we can approach this as well. So let's try to do the volume of the smaller one, just straight up, just because it's something enough students would do. So we're going to have 7 3/4. times 2 times 12. Okay, so depending on how you want to do that, there's a couple of ways to do it. We can do 28, 31 fourths times 2 times 12. All right. I would like to do that. All right, so I end up getting 31 times 6. So I can go do that. 6, 18. So the volume of the smaller one, let me write that neater, is equal to 186. Okay? Let me just double check that. And by the way, we could have used 7.75 here and used decimal multiplication. Could have done that as well. We could have made this 24 and multiply that out. Okay, I'm going to just leave that as an exercise for you guys to do on the side. Because I've solved this before and I know the answer is 186, so I'm not going to do that. The volume of the larger one is also going to be 7 3/4 times 2 times, we don't know what the H of L is yet. Okay, so we need to actually go and now apply this 80% of the larger box. Okay, so if we use that formula again, we know the height of the smaller box is 80% of the height. Wait, the height is small, that should be an S. The height of the larger. We know the height of the smaller is 12. So 12 is equal to 80% of the height of the larger. Okay, and if we multiply the right-hand side by 100 over 80, okay, that cancels that, that cancels that. Whatever we would do to one side, we'd do it to the other. So we're going to multiply this by 100 over 80. Okay, and all we have to do now is compute that. All right. So we're going to get, let's see, where can I do this? I can do it down here. So I'm going to cross out this 0 and this 0. So I get 12 times 10 is 120 over 80. Sorry, over 8. All right. So 8 goes into 120. 8 into 1, no. 8 into 12 once with 4 left over. 8 into 45 times. So we get 15. So this means this was 15. Okay. Does that make sense? 80% of 15? Let's do that on the side, just to verify and check what we're doing. It's always important to check your work. 15. So this 0 and that 0 goes away. 5 goes into here twice. 5 goes into here 3 times. Okay. And this 2 goes into this 4 times. And we end up with 4 times 3, right? And that is 12. All right, so that's our new length. So that means we have 7 3/4. And we know that's 31 fourths from above. We can redo it just to be sure. 28, 29, 30, 31. 31 fourths times 2 times, now we have 15 instead. Okay, before I canceled this 4 into the 12. I can't bring the 4 into the 15, but I can take this 2, Okay, and bring it into there and make that 2. All right? So now I'm stuck with some slightly ugly computations to do. I still have to do 31 times 15 and divide that by 2. My throat's giving out so bad. So we get 5, 15, 1, 3. I'm going to scroll this up slightly so we have a little space there. Let's see what I do. The 5, 15, 1, 3. So we get 5, 6, 465. Okay, I'm going to do that opposite. 15 times 31. I get 15, 5, 1, 4. Okay, 465 again. All right. And we're going to divide that by 2. Two goes into 4 twice. 2 goes into there 3 times. We're going to have an odd thing here twice. 1 left over, 0.5. So we get 232.5. All right. So that is what the volume of the large one is. So now let me just change this one more time so we can kind of follow this. I'll use green, I guess. So now we need to be subtracting those two numbers because we need the difference. We have the volume of the large and we have the volume of the small. So we need to do 465. Sorry. 232.5 minus the 186. Okay. So this 186 is the same as 186.0. Okay, we need to borrow. Oh wait, no we don't. We get a 5. This is 186. So we're going to borrow here. We get a 2. That's 1. That's 6. And then we have 18 to 23. We can borrow one more time if you want. And we get a 4 there, right? That was a 6 actually. So we actually get 46.5 is the difference. Okay, so that is the answer to this question. This is a pretty long question. Look at all the math all over the place. There is another way to solve this. Let me change the color to this fuchsia thingy. All right, so what we had was the volume of the small was equal to the 7 3/4 times the 2 times the 12. Okay, the volume of the large was equal to the 7 3/4 times the 2 times the 15. This is the same, 7 3/4. 2 is the same, but the difference between this is 3. All right? So what we really need to do is do the 7 3/4 times 2. You can almost do that in your head. We get 14 plus 1.5, I guess, which is 15.5. If I did that right. Right? You understand what I'm saying? 7 3/4 plus 7 3/4 gives us 14. And 3/4 plus 3/4 is 6/4, which is 1 2/4 or 1.5. So we get 14 plus 1.5, so we get 15.5, 15.5. And what all we need to do at that point is multiply that by the difference between these times 3. Okay? And if we do that on the side or in your head, because that's simple enough at that point, 15.5 times 3. 5 times 3 is 15, carry the 1. 5 times 2 is 15 plus the 1 was 6. And that gives, carry the 1 again. 46.5. That's the number we got over here as well. All right, so that's our double check. It's also a much more cuter and faster way to do this. It involves a lot less of these computations. And again, I could have done this in decimal. I could have done 7.75 plus 7.75 times 2. Normally, I like to use times 2 because you just double things often. That becomes a handy way to do stuff. So there's different ways to look at different stuff. If you remember some of the geometry questions where the one last from part 2 involved the trapezoid, where we could use the whole shape. We can use the formula to get the area of a trapezoid, or we can build up each part, take it as composite shapes is called, and take the area of the triangle and then the area of the rectangle and add them together. There was also another solution, which was to put a rectangle around the whole thing, get the area of the whole rectangle, and then remove out that one triangle. So depending on the viewpoint that you want to solve problems for, there's a lot of different ways to do this. No matter how you slice this, this was a geometry problem. It was in particular about the volume of a rectangular prism. It involved multiplication no matter what. So you can never avoid that, guys. All right. And was there any? Yeah, the 31. So multi-digit multiplication. And it was a word question because you had to do that 80% thing. So it involved percent too on top of it. Yay. Okay. All right. So that's the concepts that was behind that. And eventually the whole end. So the difference, we're taking the difference in volume. Volume will be in cubic inches. And by the way, these were all in inches. 7 3/4 inches, 2 inches, 12 inches. So we always want to double check if we had to do unit conversion. We didn't have to do a unit conversion. And we didn't have to convert to any other part of the thing here. This problem blows a lot of students' minds. But here we go. The area of Brian's rectangular garden in square feet can be found by using this expression. Okay, so we have 6 times 2x plus 5y. They're telling us that this is equal to the area of Brian's garden. Okay, just making sure I copied that right because I have dyslexia. Yep. Use the distributive property. They're telling you this is not a hint. They're literally telling you to use the distributive property to write an equivalent expression. So we need to apply the distributive property. So that's A times B plus C. A times B plus C is equal to A times B plus A times C. And you don't need these parens. We could have just said AB plus AC. Okay, so we're going to apply that same thing. A would be this would be B, the whole thing, 2x, not just the 2, and C would be 5y, not just the 5. So we're going to do 6 times 2x plus 6 times 5y. Okay, so that's equal to 12x plus 30y. Okay, that's what they're looking for up here. 12x plus 30y. Okay, use the distributive property to write it. Okay, there was another example a couple days ago where I said you could kind of split this up. You could have done 6x plus 6x plus 1y plus 29y. Okay, that's not good on this question because it says use the distributive property to write the equivalency. Okay, this thing I scribbled out, that's not the distributive property equivalent version. So it has to look like this form specifically. Technically, 30y plus 12x is allowed. Because you can argue when we do this, why isn't AC plus AB? Well, it can be. Okay, so there's nothing in the distributive property. There's no law. This is a mathematical consistency, these properties and laws and stuff and rules. This is not set by governments and stuff like that. There are standard bodies and so on that establish some various different things, but not here. Okay, all right. So that's kind of where we need to go with this. It is not the end of the question, though. Okay, so there's another part right here. Okay, and by the way, what's different about this question is it actually uses this thing right here. Some of the other cases where it said write an expression, it just puts it in the paragraph, and it's up to you to put it in the show you work part. Here they're specifically saying, hey yo, put the equivalent expression. So it says use your equivalent expression to find the area of Brian's garden in square feet if x is 3 and y is 4. So all we have to do is substitute them. 12 times 3 plus 30 times 4. Okay, 12 times 3 is 36. 30 times 4 is 120. And 120 plus 36 is 156. Okay? Let me just double check I have everything right there because, again, I have dyslexia. So I have 6 times 2x plus 5y. That becomes 12x plus 30y. Cool. And then x is 3, so that's 36. Cool. And y is 4, that's 120 and 156. Yep. So it's definitely 156. There's no units to this question, so it probably just has an underline with nothing else there. Okay, it's square feet. Oh, well, yeah, actually you told us that, okay. And again, there was no unit conversion. All we're doing is taking that algebraic distributive property and applying it to it, okay. So this is about algebra. It's about using the distributive property, and it's about substituting values properly, all right. There are some scenarios of x and y with negative numbers that you need to watch out, and that's why I use this paren, 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 this paren. Okay, because we want to make sure we're getting those right. All right, and that because negative signs can screw up a lot of problems. All right. I guess this can go wrong in a lot of ways. So first of all, make sure that you're writing the right equation here. Okay, and then substitute it in directly like I did. All right, be careful with some of these things. Then you can get led astray with it. Okay, that's 57. 58. I can see already it's using set algebra as well. I see this clue in here, and I see write an equation. Okay, so in this case, they want us specifically to do something with C. Okay, so at some point we're going to use C. Usually you want to say C equals, but when they say write an equation to represent C, then it doesn't always have to say C equal. Just involve it somehow. Okay, all right, anyway, let's read. Hotel has a number of meeting rooms, M. M is the number of meeting rooms. Each meeting room has 325 chairs. Write an equation to represent the total number of chairs in the meeting room. So it'll be 325 times the number of chairs. I said that backwards. The number of chairs is 325 chairs per meeting room, right? Each meeting room has 325 chairs. So it's 325 times the number of meeting rooms. So if there's one meeting room, there'll be 325 chairs. There's 2 meeting rooms, there'll be 650 chairs. There's 10 meeting rooms, there's 3,250 meeting rooms. All right, so that's awesome. And then it says, if M is 7, use your equation to find the total number of chairs. So it's 325 times 7. 7 times 5 is 35. 3, 14, 7, 1, 21, 22, 75. And I would do that a second time. We can just make sure. 325 times 7. 7 times 5 is 35. 3, 14, 7, 1, 21, 22, 75. right? That's a 2 over there as well. 2275, right? That's all they're looking for that. Interestingly, where I'm pulling this from, the other questions were all worth 2 points. This one's worth 3 points. I would have thought the previous question was when one a couple ago where we did a lot of computations. I think the volume with the serial box seems more involved than this. But anyway, it's about this mapping. This mapping is, you have to really think it through. And once you get your equation, use some test numbers. Try to make sense of it, okay? Obviously, one meeting room will be 325 chairs because that's by definition what they're telling you, all right? So you don't want to start doing 325 times M or M over 325, right? It can just start getting whacked out. There are alternate forms of this, though, because if C equals 325M, if I was to divide both sides by M, then it turns out that C over M is also 325. Okay? We could also say C equals C over 375 is equal to M. That's also true, right? Because if we start again with C equals 325M, if we divide both sides by 325, that cancels. What we do to one side would do to the other. So we get C over 325 is equal to M. So it depends what you're trying to be asked to solve. And in some cases, it's easier to use different formulas in different ways if there was a fraction, if there was a decimal number, whatever the case may be. So again, I found this easier than some of the other questions on this group of questions, but so be it. This is worth more. Again, it's about algebra. The previous question was about algebra as well, where you had to do the mapping, right, with X and Y and so on. Right, algebra involves using symbols and coefficients and terms, stuff like that. All right, and still involve multiplication, and we still need to get that right. And use common sense. Again, obviously 10 rooms will be 3,250 chairs. So 7 rooms will be 325 times 7. And you should be able to give an assessment of that. If it was 300 times 7, that would be 2,100 chairs. So you know your answer. If you got 10,000 for your answer, about 22,000, you're far off. So you can always use these estimation skills. And then the answer has to be in chairs. All right, let's see how we're doing on time. We're at 58 minutes, and we have 2 more questions. So let's see what we can pull off here. Let me see. I lost my tab by checking that. Jimmy and his family are on their way to visit some friends who live 780 miles away from them. Based on the route they choose, they expect to complete their trip in 3 days. The distance and average speeds for the first 2 days are shown below. So on the first day, I'll use 1:: they spent 4 hours going at 60 miles per hour. Okay, so that means they did 4 hours times 60 miles over an hour. Okay, the hours cancel, so we're left with 240 miles. Okay, on the second day, they did 6 hours at 65 miles per hour. So 65 miles per hour. Okay, the hours cancel again, so we're left with 6 times 65. Right, you can do that on the side. 65 times 6. 6 times 5 is 30, 0, 3, 36, 39. Okay, so it seems like on the second day, they did 390 miles. Okay. If the average speed on the third day was 60 miles per hour, how many more hours will it take them? All right. So we don't know that. That's X. So they did X at 60 miles per hour. All right. Well, we know the total they went completely. So what you want to do is add the 240 and the 390. So we get 0, 4 plus 9 is 3, 1. So we get 630. Let me just make sure I did that. 6. Yeah, 630. So we're going to do 780 minus the 630 is going to give us 150 miles. All right? So it means this is going to have to be equal to the 150 there. So to be clear, we have X times 60 equals 150. So we divide both sides by 60. Okay, so we get X equals that. We can cancel these out, right? And you should see already 6 goes into 15 twice. That's 12 with 3 6 left over, or 2.5, or 2.5. Depends how you're looking at it. And that's the answer. How many hours did it take him? It took him 2.5 hours. Right? We can plug that back in. Right? 2.5 times 60. 60 plus 60 is 120, and half of 60 is 30, so 120 plus 30 is 150. So we can check it, okay? Or you could have done 2.5 times 60. That's 0. 6 times 5 is 30, 0, 3. 12, 13, 14, 15. This is over 1 decimal. That's over 1 decimal. And we get 150. All right? That's what they're looking for there. So this is really a word problem, splitting up the parts, using a lot of rates, right? 60 miles per hour. And then just finding out the number of hours to find out how far they went. And then for the last case, we have to do it backwards based on the total number of miles, based on what they went so far, do the subtraction to find out how much is left, the 150, and then go for the rest of it, okay? So this was about basic operations involving a word problem, but also setting up rates. So that's 59. And again, the answer had to be in hours to make sure it made sense. So we're always kind of double checking that kind of a thing. All right, 60. And by the way, this was worth 3 points as well. And I think the question before it was as well too. I may have mentioned that the cherry one was worth 3 points. Yeah. All right, we still have 2 problems left. So we're going to run over the hour. And we probably are already. Yeah, we're an hour and 3 minutes. So let's see. Okay, I believe the last problem is simple. So this one is probably the nastier one. So there's a right rectangular prism. I'm semi-sensationalizing it because I draw these so horribly. Okay, so it says it has a length of 2.5 feet. Okay, a width of 3 feet and a height of 1.5 feet. Okay, so far I see no unit conversions. So just to be clear, this was the length, this was the width, and this was the height. So we can just keep following the story along as they give it. Okay, unit cubes. So these are cubes, meaning the length of the sides of each one are the same. Okay, unit cubes are 1/2 foot. So there's a 1/2 foot there. There's a 1/2 foot. So the front is a 1/2. This side here is a 1/2. Okay, and the height is also a half. So this is a 1/2 by 1/2 by 1/2. By definitions, that's what a unit cube is about. It's the length times the width times the height. They're all the same. Otherwise, it wouldn't be a cube, right? So anyway, it says unit cubes with side lengths of this are added to completely fill the prism. So these thingies here, they're all put inside of here to fill that up, all inside, okay? So it says what is the volume in cubic feet of the right rectangular prism? So first of all, we kind of just did that with the serial example. So what we need to do is the volume of this thing here is going to be the length times the width times the height, okay? So we're going to have 3 times 2.5, or 2.5, times 1.5. Okay, so that's what they're kind of asking us to do in the first place. So one thing we can do is convert this into fractions. So this is the same as 3/1 times 5/2. Okay, and I converted that 3/1 just to get the 5/2 to work nice. And 1.5 is 3/2. All right. So the numerator, we get 3 times 5 times the 3. So we get 45. And the bottom is 2 times 2 is 4. A lot of kids leave that as a 2. You guys need to make sure you know what you're doing. So that turns out to be 11 1/4 feet cubed, or cubic feet. Okay, these are the same way of writing the same thing. So we have 11 1/4. If you stuck with decimals, or you could just convert this to say it's 11.25. Okay, we could have done 3 times 2.5 times 1.5. Okay, that starts getting uglier to me, but it's possible. You could have went on the side and did that. In fact, it's probably not as ugly as it looks, because we can certainly, instead of doing the 2.5 times the 1.5, we could have done this first and got 7.5, or we could have done this first and got 4.5. So in the first case, it would be 7.5 times 1.5, or 4.5 times 2.5, depending on which one, right? So we could have used that 3 in our pocket to give us a slight advantage to doing the decimal multiplication. All right, so this is 11 1/4. You might ask, wait, what happened to these thingies? Why did it mention this whole sentence here if it never asked us to solve that? Of course, the answer is down here. So now the question is, how many of these unit cubes can be added to fill the prism completely? Use what you know about unit cubes or the length of the side of the prism to show your work, or explain your answer. Okay? So you can either show the work or explain the answer. So we can use the cube here. Let me kind of redo it a little neater. If I only use the front, okay, the front was 3 feet in the front, okay, and it had a 1.5 foot height, okay. So if we use the unit cubes, which were 1/2 foot, right, that means if we did a 3 here, that there's actually a second row of them in the front. And doesn't that make sense? If they're 1/2 foot each, shouldn't there be 6? 1, 2, 3, 4, 5, 6 in the front here, right? So the same is on the side here. If it's 1.5, right, and they're each 1/2, shouldn't there be 3 of them then? Going this way, right? 1/2 plus 1/2 plus 1/2 is not 1.5, right? So again, another way, we did 3 times 2 equals 6. We can also do 1.5 times 2, and that's equal to 3. So that would mean that if we double that, we get 5. All right? So that means that we're talking about 5 times 3 times 2. Okay, so that's 15, that gives us 30. All right? Oh, wait, sorry, I wrote 2 here. Let's back up 1 second. I wrote 3 times 2 is 2. 3 times 2 is 6. All right, so what we're going to end up with is 6 times 3 times 5. So we get 15 times 6, or 18 times 5, and we end up getting 90. Okay? So it turns out we can add 90 cubes inside of this rectangular prism here. So it says use what you know about unit cubes or the side length to show your work or explain your answer. So there's a weirdness here because you just can't double this 11.4. You can't do 11 1/4 times 2 to get the number of those cubes. The reason you can't do times 2 is because this is times 2, okay? This is times 2, and this is times 2. Every dimension is but times 2. So if you did 11 1/4 times 2, you're only multiplying one of the dimensions by 2. Okay? And mathematically, the way that makes sense is we're taking 11 1/4 and we're dividing it by this here. When I talked about the half by a half by a half, well, that's equal to 1/8. Okay? So the volume of each little cube is 1/8 feet squared. Or feet cubed, sorry. So what we need to do is take the volume of the whole thing and divide it by the volume of each little thing there. Okay, and this becomes multiplication by its reciprocal, right? When we divide it by a fraction. So we get 11, and that we can go back to this original thing then, the 45/4. Okay, so we have 45 times 8 over 1. 4 goes into 8, 2, and we end up with 90 over 1, or just 90. We get back that 90, you see there? By the way, the cancellation works because we don't want to do 45 times 8. Okay? We probably don't want to do multiplication like that. So what we try to do is figure out what cancels first. All right? Anyway, we end up with that 90 back. So it's demonstrative that that is what's going on. So this is geometry. A lot of multiplication. Mixed fractions. We could have used decimals. Go for it. Okay? And multiply a problem. And knowing your formula. Okay, last one's fairly easy. A lot of kids mess it up. We have some sort of chart with artifacts and elevations. There's different materials and items, and each thing seems to be in a relationship to sea level. Okay, I don't know where they're going with this, so let's look at the words. The table below shows the elevations at which different artifacts, these things, were found during an archaeological dig. So the elevations, okay? Write the name of each artifact and the elevation at which artifact was found using a positive integer, a 0, or a negative integer. So this is kind of silly-ish, but so it didn't have to be in order. Some students feel they need to start sorting these. You don't. It's just asking to give a positive integer, a 0, or a negative integer for each artifact's elevation. So the arrowhead is above sea level. So we want to say that's 15. An acceptable answer was probably also plus 15. Okay, the bone is 721 feet above there. So again, we could just write 721. Or plus 721. Okay, the clay bowl is at sea level, so that's 0. That's our thing. If you imagine this being a thermometer, 0 is our sea level. Sea level is where we're neutral. We can either be above sea level or below sea level, right? So the clay bowl is neither here nor there. A 0 is neither positive nor negative. Okay. The next item is the necklace. Okay, because of the way they presented this, it says 462 feet above sea level. A lot of kids go minus 462, but that's not what it is. It's actually the 462 or the plus 462. And then finally, we have the woven basket. And that is below sea level. So that one, no ifs, ands, or buts about it, that's minus 1200. Okay? And now it's asking, how do you determine if it was positive, integer, or 0? Okay? So if it was above, that became positive. I'm just going to put pause there. If it was at sea level, then that was 0. And if it was below sea level, then that was negative. I put NEG. Okay, that's all they're looking for. You have to put that in words. You just can't write this shorthand I did. Okay, that's the last question on this one. Hope you guys enjoyed some of this. I like to go exploring. Hope you guys do too. There's more of these coming, more for grade 6, plus other grades, plus other things I do. I already have hundreds of videos on the channel. Please subscribe. Please smash the like button. And have a wonderful, lovely day. Chill out, guys.